Silicon is a tetravalent metalloid with a blue-gray metallic luster. You'll find it in the 14th group of the periodic table. X4 is the universal silica composition. When it comes to photovoltaics, it's one of the most widely used materials. Among the potential candidates for a new elemental foundation for life, silicon stands out as the most feasible. It is an element that shares the same chemical properties as carbon, but which has the unique advantage of having a higher electropositive charge. The silicon bond isn't as strong as the carbon bond because the outer orbital of silicon often lacks a full complement of electrons, even when it's bonded to other atoms. Aside from its chemical similarities with carbon, silicon can form chains with itself and various heteroatoms. It also has a covalent radius larger than carbon's, which results in a ring reactivity that is distinct from carbon's. Organosilicon polymers, confidently standing on the basis of the endless supply of silica and renewable organics, maintain sustainable growth over a long time. This is primarily due to the complexity of the unique properties inherent in polydimethylsiloxane and the huge variety of its forms. On the other hand, there are three types of silicon chemistry: organosilicon chemistry, pentacoordinate silicon chemistry, and zwitterionic silicon chemistry. Each type of silicon chemistry is useful in different biological processes. The discovery of silicon is believed to have occurred nearly 100 years ago, but its importance as a semiconductor did not emerge until the early 1900s. Physicists began studying the potential of silicon as an electronic switch. Silicon was first discovered in 1824 by Swedish chemist Jöns Jacob Berzelius. He learned that it was a byproduct of his experiments with cerium, another element of the periodic table. After experimenting with other elements, he used potassium and silica to purify the material and discovered that it was a useful semiconducting substance. In the early 1940s, William Shockley worked at Bell Labs and invented the transistor. He had the vision to establish his own semiconductor firm. In 1956, he founded Shockley Semiconductor Laboratory in Mountain View, California. The company's initial work consisted of automated production of diffused base transistors. The company started experimenting with larger silicon wafers in the 1970s. In 1971, it produced the world's first microprocessor, and started development of memory chip products a few years later. Silicon, one of the numerous elements on the chemical structure, has the second highest abundance in the continental mantle. It is found in many crystalline forms, including mica, feldspar, and olivine. It is most commonly found in silicate compounds. Many different methods have been developed to transform polycrystalline into silica single crystallites. These include the zone melting method and the float zone method. However, for a high purity grade, a multi-stage process is required. Silicon has been found in many of humankind's most important milestone technologies, such as cuneiform tablets, clay tokens, and the invention of the telephone. It is an element that appears in nearly 282,000 parts per million in the Earth's crust. It is found in almost all rocks, soils, and water. Its properties made it a promising conductive material. Silicon has a high affinity for oxygen. This means that it will bond tightly with the atom. It also means that it is relatively inactive at room temperature. However, it is highly reactive with halogens. Among the most important silicon compounds are silanes. These are strong reducing agents. It is a purely electropositive element. It forms many important compounds with other elements. These include alloys with aluminum, magnesium, and iron. The chemical properties of silicon differ greatly in its natural form and in its various compounds. However, the properties of silicon can be understood in the context of the valence shell electronic configuration. Silicon forms a face-centered diamond-type cubic crystal lattice. It is a metalloid with the atomic number 14. It is a relatively inactive element at room temperature. But it is brittle and reactive at higher temperatures. This element is very similar to carbon in chemical behavior. It has 4 valence electrons. These valence electrons are in the outer quantum shell and make silicon a good reducing agent. The electronegativity of silicon is 1.9. It has an ionization potential of 8.1517 electron volts. It can be doped with a few electrons to form semiconductors. Silicon nitride is a remarkable material with a number of outstanding properties. It is quite strong and robust, and it conducts electricity very well. It has a unique chemical composition that allows it to exhibit exceptional thermal properties. The element is used in a variety of applications, from computer chips to solar cells. In addition, It is a key ingredient in super sturdy ceramics. It has been the basis of numerous milestone technologies. This was utilized, for instance, in the creation of the earliest computers in 1954. It was also the first electronic switch to amplify a signal. It is also a major component of aerolite meteorites. Silicon compounds are often used as sealants and are resistant to chemical attack. They are also used in waterproofing treatments, caulking compounds, and mechanical seals. Besides being a component of the electronic industry, silicon is used for many other applications. In the medical field, it is an essential element for pacemaker leads and dialysis tubing. It is also added to cosmetics and hair conditioners. It is sometimes used in contact lenses and breast implants. Silicon nitride is also used as a passivation layer for silicon components in integrated circuits. Another application of silicon nitride is as a chemical barrier. It is used to form a layer between two polysilicon layers. This results in improved functional integration.